Today we're going to be fixing a Vestax PDX-2000 MK2 with the UCOM 5V line problem. You can see here when turning on the power switch, none of the LEDs are lit and the start-stop button is unresponsive. Sometimes you can fix this by turning it on and off again very quickly. You might get the lights back. You see there, they're now responsive. There's only a short fix. Things you're going to need: you need a Phillips or preferably a JIS screwdriver, temperature controlled soldering iron so you don't burn the pads off, some solder, preferably 60-40, two 10 microfarad SMD capacitors. You can optionally have flux, isopropyl alcohol, or tweezers. So start off by removing the M3 screws off the platter, and you should just be able to lift that straight off. I'm just going to put them aside somewhere. Flip the turntable over and place it on a saucepan or a wok, just so you've got enough clearance so you don't go and damage the tone arm. And then what you need to do is then take off the back lid. Obviously make sure you've turned off the turntable and it's unplugged from the mains. Now we can see inside. Here we've got the start-stop button and speed selection, got the mains transformer, power supply element of the circuit board, going up to the driver transistors, the tone arm wiring, and then we've got the UCOM board just here next to the pitch fader. And there's the motor in the middle. Check the placement of the screws here. We've got two countersunk screws which are in an unusual position, and the rest are pan. Just make sure they go back in the right place. So begin by unplugging all of the connectors just here. It'll make it a lot easier if you can just get this away from the turntable, and then you've got a bit more clearance as well. It's not very easy doing it one-handed when you've got the camera as well, so it took me a bit longer than needed, but there we go, and we can see the board just there. Now the cause of the problem is actually coming off these two capacitors just here. These are both 10 microfarads, and they're responsible for kind of smoothing out the 5V line which goes to the microprocessor. Here I'm just putting on a bit of flux just to kind of help with the desoldering. It will just kind of make the old solder joints a bit easier to work with. So I'm retinning here just to kind of help things start to move. Just on the positive and the ground side, you can tell by the polarity with the black side is where you've got ground. And we're just going to really carefully heat up the pad and just give it a gentle wiggle. And eventually they'll start to kind of just come loose. Don't try and force it because you'll damage the pads, but just very gently heat it up. And eventually you'll see the cap just comes straight off. Do exactly the same on the other one, and eventually they'll come off. So using this Atlas LCR component analyzer, you can see here that the capacitors, instead of being 10 microfarad, they're actually just 200 picofarad, which is like 0.002% of what they should be. So they're completely dead. And it's no surprise that they're just unable to kind of smooth out the real voltages it needs. Here I'm just using some isopropyl alcohol just to clean the pads in preparation. And here we've got the two caps that we're going to be using. These ones are Nichicon, they're made in Japan, they're really good quality. Got a life of about 1,000 hours, so that should be plenty of time. And they're really kind of highly rated. To make life a bit easier for myself, you don't have to do this, but I just pre-tin the leads, just so that when I go and heat it up later, it's just a lot smoother for it to adhere to the existing pad surface. Most of the time you don't need to do it, and you could always do this with a hot air gun as well, but I've found it works really well for me. So here we're using a pair of tweezers, making sure the polarity is correct as well as before. I'm just going to heat up that lead and the pad at the same time. Just make sure that it's secure on one side, and then we're going to do it on the next side. And we're just going to kind of press it down slightly whilst I'm doing that, just to make sure that there's a nice good connection between both pads. Now I'm slightly worried here that there's a bit too much pressure just on one side, so what I'm just doing is I'm going back and just retinning both sides, just so it's kind of a bit more of a better finish. And you can see it from this angle too. So starting off with the positive, because it's got a smaller surface area, so it's a lot easier to heat up. We're just going to heat that briefly, and then we're going to switch to the ground side and do exactly the same thing. So once they're both attached, then just go back over one at a time, just to make sure the joints are really nice and smooth. This is where it really helps using 60/40 leaded solder. Non-leaded is absolutely fine, but I just find it's a lot easier working with the lead solder. So once that's all done, what we're now going to do is we're going to go and reinstall it. Just pay attention to where you had the screws previously, and we need to make sure that we put all the cables back in as well. To kind of make sure that we're not damaging the chassis, I usually twist in reverse the screw just so it can find the actual thread. Once it's kind of started to bind, then I'll turn it clockwise to then screw it back in. And that way you avoid just threading the plastic standoffs. And once we've done that, we just need to reconnect. That's the LED lights. We've got the motor, the speed connections, the pitch fader, and also the remote start and stop. So make sure those are all back in to make sure it works. Once that's done, it's all for testing. So here it is, all reassembled again. Pressing the start-stop button, and it works perfectly.